Hello, thank you for tuning into our live stream for AskRose Homework Help. I'm Alex Gonzalez. I go to Rose-Hulman Institute of Technology and I'm a civil engineering major, and today I will be helping you all review for the AP Calc AB exam. So to jump right in, we're going to be talking mostly about the AP free responses. What are they like, what to expect, how long they are. For the free responses, you have 6 questions for a total of 1 hour and 30 minutes, which is worth 50% of your exam score. Part A is 2 questions for 30 minutes. Graphing calculator is required. And for Part B, it is 4 questions, 60 minutes. You do not get a calculator for this part, so you will have to do it all by hand. These questions include various types of functions and function representations and a roughly equal mix of procedural and conceptual tasks. Questions include at least 2 questions that incorporate a real-world context and scenario into the question, so there will be a lot of word problems and things like that. So here we have an example of an AP Calc AB free response. It says the density of a bacteria population in a circular Petri dish at a distance r centimeters from the center of the dish is given by an increasing differentiable function f, where fr is measured in milligrams per square centimeter. Values of f of r for selected values of r are given in the table above. Use the data in the table to estimate f prime of 2.25. Using correct units, interpret the meaning of your answer in the context of this problem. So in order to do this question, you have to use the table to estimate what f prime at 2.25 will be. So on our table that we have right over here, we are given r in centimeters, 0, 1, 2, 2.5, and 4, and f of r given in milligrams per square centimeter. Interpret the meaning of your answer. So we have to estimate what f prime will be when r is 2.25, so between these two values. So when we do a problem like this, you have to consider that r is the radius of your population in a circular Petri dish. So for these type of problems, I like to draw a diagram to kind of represent what's happening in the function. Population in a circular Petri dish. So let's say this is our Petri dish. This is the center, and we have different populations at different radii. These are our r values, and f of r is where what the density of the bacteria population is. So we have f of r get my eraser real quick. Can I see the answer for this one real quick? Okay, so for this one, we want to use the different values of our table to estimate what f prime will be between these 2 points. And so in order to do that, we can estimate that f prime of 2.25 will be approximately f of 2.5 minus f of 2 over 2.5 minus 2. And we do this because if you were to look at the graph, you can make a graph right here really quickly. And we say this is 2 and this is 2.5. We have exact values of what that's supposed to be, 6 and 10. but we're trying to find an estimation on the value between there. So we use calculus to find an estimation of what that value should be between these 2 points using the information that we have. So using this estimation that we have over here, we find f of 2.5 is 10 minus f of 2 is 6. 2.5 minus 2 is 0.5. So we have 4 over 1/2, which gives us 8. And in correct units, that would be centimeters, because at a distance of r equals 2.25 centimeters from the center of the Petri dish, the density of the bacteria population is increasing at a rate of 8 milligrams per square centimeter. So the units for this would be milligrams per centimeter squared, because if this function is given in milligrams per centimeter squared per square centimeter, then we have to find the rate at which that it is changing between these two. So this is the rate at which the density of the population is changing at this point. For part B of this problem, the total mass in milligrams of bacteria in the Petri dish is given by the integral expression of 2 pi times the integral of r times f of r dr from 0 to 4. Approximate the value of this integral using a Wright-Riemann sum with the 4 subintervals indicated by the data in the table. So for this one's a little bit more involved because we specifically have to do a Wright-Riemann sum, but that's okay because we have all 4 values that we need for our Wright-Riemann sum. So really quickly, if we had a graph like this, and we had x values here, then a Wright-Riemann sum would take the values at the rightmost. So if we wanted to get the Riemann sum at this interval, then we would get the point on the right. So we would find the value there and do that for every single interval that we have. What this gives us is an approximation of the area under this graph by having different widths and lengths. Your width is your delta x, so the difference between 0 and 1 for here, the difference between 1 and 2, difference between 2 and 3, and so on. And your height would just be the y value for each of that. So you'd multiply the y value by your delta x and do that for every single rectangle, and that would give you your approximation. So let's do that for this problem. For this one, approximate the value of, okay, so for our integral, which we will later multiply by 2 pi, our Riemann sum will be 1 times 2 plus the difference between 1 and 2 is 1 I'll put these in parentheses so that way you can see what it is I'm multiplying by. The right value for that one would be 6. The difference between 2.5 and 2 is 0.5. 10. The difference between 4 and 2.5 is 1.5. Multiply that by 18. So that'll give you your approximation for this integral by using the rightmost values for each, the rightmost values for each of our different rectangles. And so to solve for this, you get 2 plus 6 plus 5 plus, let's see, 27. That equals 8 plus 32 is 40. So our approximation for the value of this integral that we're to solve for using a right-Riemann sum would be 40.
B.
Hmm?
Is that for part B?
Yeah.
There's a case right there.
Oh, you have to multiply by 2 pi. Forgot about that part. Yeah, so let's see.
Wait, not having a calculator.
Yeah. I'm trying to see where, so 2.5 times So looking at the solution for this problem, it says that you have to do 2 pi times the whole thing, which is the step that I forgot to do. 1 times f of 1 times 1 minus 0, so the difference between our x values, plus 2 times f of 2. So they're saying that you have to do x times your y times your delta x, which feels like you're multiplying x twice. Ah, okay. It's because you have to multiply r by it for that specific Riemann sum. So the step that we would add to the work that we did right here is multiplying our r values. So for this one we would multiply 1, for this one we would multiply 2, this one we would multiply 2.5, and for the last one we would multiply 4. Okay, so that's my fault for forgetting that we are not just taking the integral of the function, we are taking the integral of the function multiplied by our values as well as 2 pi. So to remedy that real quick, we will rewrite let's bring 2 pi out front, and we'll multiply the exact same thing we did earlier, except this time also considering our r values. So we have one times 2 times 1, our delta x, plus 2 times 6 times 1 plus 2.5 times 10 times 0.5, our delta x for that, and then 4 times 18 times 1.5. And so for this one we would get 2 pi times 2 plus 12 plus 5 over 2 times 5 plus 4 times 27, which is equal to roughly 845.088. And since it is a AP exam, they do like you to put 3 points after the decimal as a rule of thumb, and so that would be where you cut off your approximation. So part C of this question is asking, is the approximation found in part B an overestimate or underestimate of the total mass of bacteria in the Petri dish? So when I was explaining how we do Riemann sums, I gave this curve as an example. So when you do a Riemann sum, when you do a Riemann sum, you're taking the rightmost values of your function and finding your approximations that way. So because you're taking the right ones, this one would be an overestimate. An example of a right Riemann sum that would be an underestimate would be a curve such as this. Excuse my inability to draw a curve. Then you would take rectangles like this. But as you can see, there are little gaps under the curve. So this one would be an overestimate and this one would be an underestimate. So for our estimation of the graph that we have to consider I'll do it on this one because we have the graph over here. If we have a graph from 0 to 18, then we have, let's see, 10, 5, 0, 1, this is 9, this is 18, this is 4, 5. Oh, whoops, I'm looking at the wrong axis. So our 1 would be 2. Let's make this 18, 9, and such. So this one will be 2. This one will be 6, 10, and then 18. And we have our curve going like this. So this curve over here is a little bit more representative of the curve that we have in this example, since let's do this as a representation. So because this curve is increasing, then our approximations are taking account for the larger values on the graph versus the smaller ones. So if you know how to do a right Riemann sum, you should be able to do a left Riemann sum, where you would have the lower values of your rectangles in your estimation, giving you an underestimate. But since we are taking a right Riemann sum, we would have an overestimate. So for this one, we would have an overestimate of our values because our graph is concave up, meaning it is positive and increasing. And our right Riemann sum takes into account the larger values of our graph. So for part D of this problem, the density of bacteria in the Petri dish for 1 is less than or equal to r, which is less than or equal to 4, is modeled by the function g defined by g of r equals 2 minus 16 times the quantity of cosine of 1.57 square root of r to the third power. For what value of k, 1 being less than k is less than 4, is g of k equal to the average value of g of r on the interval 1 is less than or equal to r is less than or equal to 4. Okay. So for this one, we need to set up an integral for our average value of g. So because we are looking for the average, we need to set up a kind of ratio that tells us how many values we are doing, because your average is adding up all of the different values over the number of values that you have. So because we're taking it from 1 to 4, then we would do 1 over 4 minus 1, as kind of our coefficient to that. And we'll take our integral from 1 to 4 of g of r with respect to r. And so if we do that, then we get 1 over 3 dr. So for this one, I would recommend using your calculator to solve this one, because this integral is possible to do by hand. However, it is very involved and will take you longer than you would want to spend on the fourth part of an exam question, because you don't have that much time to solve for this one. So for this one, you could plug this one into your calculator, set your bounds from 1 to 4, and you would get an answer of 9.876. And so that gives you your G average. So for what value of K on this interval is G of K equal to the average of that? So we don't just want to find our average G. We want to find our value of G of K that is equal to G of R. So we essentially want to find at what value of K do we get our G average. So we want to find where this equals this, which we just found as 9.876. So to find which value of K to plug into G to get this answer, presentation. Okay, yes, so you just plug in your G and find which value of K, and your K value would be 2.497. Okay. Which is a fitting answer because it is between 1 and 4, so it satisfies the restraints given in the problem. So moving on to the next example, a particle P is moving along the x-axis. The velocity of particle P at any time t is given by Vp of t equals sine t to the 1.5 power. For 0 is less than or equal to t is less than or equal to pi. At any time t equals 0, particle P is at position x equals 5. Okay, so that just gives us our initial x position when t is 0. The second particle Q also moves along the x-axis. The velocity of particle Q at time t is given by V of qt equals t minus 1.5 times 1.25 to the t power. For 0 is less than or equal to t is less than or equal to pi. At time t equals 0, the particle Q is at position x equals 10. So find the positions of particles P and Q at time 1. So find the positions of particles. So we're given equations for velocity, and we want to find what the positions are for those two. So we have to set up integrals for both of them to find where they would be at t equals 1. So for x of p, we could set up our integral as 5 plus because our initial position is 5, so you have kind of a head start where it starts at the 5 position and then it travels for a certain amount of time. And so we would take our integral from 0 to 1 because we want to find where it is at 1. Yes. So we would get 5 equals, nope. We would get 5 plus sine of t to the 1.5. You can plug this into your calculator and it should give you an answer of about 5.371. There are no units given in this problem, so I assume you don't need them, but this would be any unit of length or distance. For Q, we would do a similar thing of setting up your integral. This time it starts at 10. Same deal, you're going from 0 to 1, v of q this time, t, and then you're taking the integral with respect to t, so you'd have 10 plus your equation of t minus 1.5 times 1.25 to the t power with respect to time. Plug this into your calculator and that should give you a different answer. That you can also plug into your calculator. We're setting up a poll here really quickly for the people watching the stream. Anyway, so if we go back to this, then you can plug this exact equation into your calculator and it'll give you an answer of about 8.564. And that's it for part A of this question. For part B, are particles P and Q moving toward each other or away from each other at time t equals 1? Explain your reasoning. So in order to answer this problem, you would have to look at the directions that these two are moving in. So can you scroll down, please? You'd have to look at the direction that these particles are moving in, and for this you'd have to consider what their velocities are at this time. So you would have to solve for v of p at 1 and v of q at 1. So you take sine of 1 to the 1.5 power, which is just sine of 1 but in decimal form. That's 0.841471. You don't need a decimal that long, but and so because it is positive, it is moving to the right. And so for this one, we have 1 minus 1.8 times 1.25 to the 1 power, which gives you negative 1, which is less than 0, negative number, so this one's moving to the left. So because, well, you also have to consider the positions at time equals 1, because if this is the x-axis, if P is over here and Q is over here, P is moving to the right and Q is moving to the left, then they are moving towards each other. If, however, P is over here and Q is over here and P is moving to the right and Q is moving to the left, then they're moving apart from each other. That's where you would use your answer in the first one. So if P is at 5.4 roughly and Q is at 8.6 roughly, then if you put that on a number line to compare, or if you put those on the x-axis to compare where they are, and we put this is 5 and this is 8, then they are indeed moving towards each other. So they are moving towards. For part C of this problem, find the acceleration of particle Q at time t equals 1. Is the speed of particle Q increasing or decreasing at time t equals 1? Explain your reasoning. So to find the acceleration, we have to take our function of vq of t and find the derivative of that to find the acceleration. So we want to find what the derivative of our equation is at that time. So our equation for Q is t minus 1.8 times 1.25 to the t. So t minus 1.8 times 1.25 to the t squared. But we're not just trying to find the function of the acceleration, we're trying to find what that acceleration is at 1. So to find that, we would have to take the derivative of this, which would give you t times 1.25 t minus 1 plug 1 into there and you get 1 times 1, because this would be 1 minus 1 is 0, anything to the 0 power is 1, times 1 minus 1.8 plus 1.25 raised to the 1 power is just 1.25. So you'd have an answer of negative. You could also plug this into your calculator and find that your answer is approximately 1.027 or 1.026, depending on how you round it, at time equals 1. The second part of this question is asking, is the speed of particle Q increasing or decreasing at time equals t? So you might think that because our answer is positive, that the velocity is increasing, but actually, if you remember from part B, we found that the velocity at Q at time 1 is negative, so it's going in the negative direction. If it is going in the negative direction, if our velocity vector is going in the negative direction, but our acceleration vector is going in the positive direction, that means that over time, our velocity vector gets smaller and smaller and smaller until it begins to increase in the positive direction. So our velocity at time 1 is actually decreasing because our velocity and acceleration have opposite signs. For part D, find the total distance traveled by p over the time interval 0 is less than or equal to t is less than or equal to pi. So for this one, you have to set up an integral going from 0 to pi of v of p, vp of t with respect to dt. So for this one, because it's trying to find the total distance and not necessarily the displacement, you'll go ahead and put this under or inside an absolute value sign, because that way you just find what the value of the distance is and not necessarily if it moved in the positive or negative direction. That's not what we're focused on. So sine of 1.5 to the t dt. This is what your integral should look like when you're solving for that. Plug this into your calculator and you should get an answer of 1.93148 over the interval from 0 to pi. You can also do this as a sum or difference of definite integrals, but the easiest way to do this is just to take it over the whole interval. Yes, this problem doesn't have any units or anything, but this would be a distance, so it would be measured in length. You also want to make sure that your calculator is in the right mode, or else you will get a different answer. Yeah, okay. So for part B of the exam, you do not get a calculator for this one. I believe we only have about 10 minutes left, but we will try and go through as many questions as possible. So a company designs spinning toys using the family of functions y equals cx times a quantity of 4 minus x squared under a square root, where c is a positive constant. And the picture above shows the region in the first quadrant bounded by the x-axis in the graph of y for some c. Each spinning toy is in the shape of a solid generated when such a region is revolved around the x-axis. Both x and y are measured in inches. So find the area of the region in the first quadrant bounded by... Okay, so for this one, we want to find the area in the region bounded by this, so the area all under this graph. So for part A, we want to find what that is if c equals 6. So to find the area under that, well, first we need to find where our bounds are, because the value over here is going to be different depending on what your c is. So your lower bound for this integral will be different depending on what c is. So first you have to plug in cx, oops, well, that's okay, 4 minus x squared equals 0. Our different x values for where that is satisfied, our different x-intercepts are x equals 0 and 2, because if you plug in 0 for x, then you get 0 times 0 equals 0, which works. If you plug in 2, then you get 12 times 4 minus... Yes, is 0, so you get 12 times 0 equals 0, so that also works. So you would set your bounds from 0 to 2. For this one, you would need to use u substitution equals 2x. So you would let u equal what's under your radical, so 4 minus x squared, and let du be negative 2x dx. You can substitute that and make it negative 1/2 du equals x dx. And that'll help you substitute out this x that's out front. After doing that, then you get your integral equals don't forget to change your bounds once you do u to u substitution. 6 times negative 1/2 root u du equals negative 3. Solve for that and you should get 2 times u to the 3/2 power. Since you have 0 and 4, then you would go ahead and switch the sign for that and then switch where you are evaluating the integral at. And you have 2 times 8 equals 16 as your final answer for the area under that graph. So it is known that for y dy is equal to c times the quantity of 4 minus 2x squared over the square root of 4 minus x squared. For a particular spinning toy, the radius of the largest cross-sectional circular slice is 1.2 inches. What is the value of c for this spinning toy? The radius of the largest cross-sectional area is... okay. So, for this one, you are given what the radius for the largest cross-sectional area is. So, if you have the graph over here of the spinning toy, oops, I'll make it like that, then it is talking about the largest radius that you could have of a cross-sectional area. So, the largest distance between your y value and the x-axis. So it's saying that for a particular toy, the largest radius is 1.2 inches. So you have to then find c for this particular toy. So if you have this function of a derivative minus x squared equals 0, and your x value that you were trying to look for is root 2. You would then plug that into your y equation and get c times root 2 times root 4 minus root 2 squared equals 2c. You do some simplifying and you find that this is just 2 squared, so root 2 times root 2 is 2, so 2 times c. So 2c equals 1.2, the largest area that you were given. You solve for c and you get 0.6. Part C of this one is for another spinning toy, the volume is 2 pi cubic inches. What is the value of C for the spinning toy? So instead of the radius, you get the volume this time. So for this one, you actually have to do what the volume of the whole spinning toy would be if this area was revolved around the x-axis. So to find your function for volume, you have to set up your integral from 0 to 2 of pi times cx times, 4 minus x squared with respect to dx. Since c is a constant, you can pull that out front with pi and get pi times c squared is multiplied by our integral. Do a little bit of simplifying, you can pull this radical out as well. Get dx, and that makes this integral much easier to solve. So once you evaluate that integral, you should get that pi times c squared. That integral becomes 4 over 3x cubed minus 1 over 5x to the 5th, evaluated at 0 to 2. Your answer then should be 64 pi times c squared over 15. You're given that the volume is 2 cubic inches. So if you 2 pi cubic inches. So if you do 64 pi times 6 squared over 15 is equal to that 2 pi, you can solve for c then. You could solve for c squared and get 15 over 32 and get your c as root 15 over 32. And that's it for that question. We have just run out of time, but there are plenty of different practice questions to review, and I hope you enjoyed the stream.